Hi, everyone. I'm Giulio Tosato. My team is composed with me, Francesco Fumagalli, and Udesh. We are a team of bachelor students, first year, second year, and third year. What was our topic for this hackathon was going toward a calibration-free BCI paradigm, also known as transfer learning. So we want to apply transfer learning. Let's go on the root of what we want to use deep learning for brain-computer interface, but we need a dataset. And each dataset, each BCI dataset has a certain sampling rate, a certain number of channels, a certain channel type. And after we need to take care of the scope properties of the EEG cap model and of the window size of events. So let's say that I want to do a task of deep learning, okay? And I want to use one dataset with 55 users, 16 channels, sampled at 250 Hertz, and a certain window size of the event. And after I want to add another dataset, this time with 9 users, with 22 channels and 20 to 250 Hertz. And after I want to add another dataset because I like things complicated. And at the end, I want to use 4 different datasets because we know that deep learning, the more data you have, the more your deep learning will perform better, the more the deep learning model. And we can see we have different channel size, we have a different sampling rate, and we have also different window size of the event. So these are really heterogeneous datasets. And we have a lot of BCI dataset available online, but they're really heterogeneous. So we were trying to do something and with motor imagery and taking this dataset together, but given that they are obviously heterogeneous, there were some problems. So we asked to our main teacher, ChatGPT, and ChatGPT told us that we need a week if we are great expert, because yeah, we need to rescale and apply all the and make this data set compatible to each other. But the worst things of this answer is that we need also to rescale everything to the smallest data set. Because if we have 24 channel, 6 channel, and 3 channel, we cannot obviously take the biggest channel. We need to rescale to the smallest. So we will lose information. And this was not really clicking with our team, and we start thinking if we could do something, and instead of losing information, we could compress it. And here, the idea of autoencoders. So let me tell you what autoencoders are. When you're making a WhatsApp call, and here there is your face, and you want to pass your face from New York to Sydney in another phone. And this, so we want your face arriving here. So we train this is called an autoencoder, that is basically trained on the picture itself. So the label is the picture itself. So we can say it's a sort of unsupervised learning. We are trying, when we show a lot of picture, this autoencoder will be able to extract the most important feature in a latent space that is low dimensional. We can decide the dimension of the latent space, but usually the latent space is way smaller than the picture itself. In this way, we'll be able to compress our data, and even if we have not a really good connection, we'll be able to send and have a really nice call. So our idea is, instead of having the face of Udesh, in this case, we can have brain data. So we can train an autoencoder on brain data. And now, that's the full idea. So we have 4 different datasets, the 4 different datasets that I show you. And these 4 different datasets, they are really heterogeneous. So we can represent them in as a matrix, and we can slice them in events. And this is the only thing, the only preprocessing that I will do from now on in this dataset. Because once that we have done this, we can train each of these autoencoders. And even if the input size is variable between the dataset, the latent space, I can decide it. And I decided it to put at 1,000 features for each of the autoencoder. So it doesn't matter. I trained all the autoencoder, and after I cut away the decoder part. And in this way, now I have a standardized dataset. So all my dataset that were previously having different features, different amount of features, now they are compatible to each other. With each other, and I can create a hybrid dataset now with all of them. I can shuffle them. Obviously, I maintain the labels of the previous because the labels are not changing. If it's we were doing a paradigm between right hand and left hand, and I can give to a fully connected network, a really small network. So it's also it's really interesting because if we have a fifth dataset, we don't need to train another EEG net because we have already this dataset. We just need to train out an autoencoder, and after just train a small network. So it's also energy efficient, it's performance efficient. Okay, so how can we test if our idea is working? Basically, we have an hybrid dataset where we have all the 4 datasets inside. And this hybrid dataset, these are the standardized dataset, we're giving it to a fully connected network. And we are using as test data only one sub part of a dataset, of a single dataset. And we compare this with training the same architecture with just one dataset that is the same. So here we have the test, the dataset 3 test, and here we have the dataset 3 training. And if we compare these two things, we can make a performance comparison. Okay, once that we have done this, I'm almost finished. So we have a huge amount of data in our model, but this huge amount of data is not destroying our model. So we managed to do that. And we also saw a small amount of improvement in the feature, in the accuracy. So it was total success. We're hoping for a bit more higher accuracy, but in 24 hours, doing in 24 hours, we did preprocess of 4 EEG dataset, build 4 autoencoder, create a functional pipeline, took also 1 hour of nap because we are human, listen to AC/DC from 1 a.m. until 6 a.m. and solve problem all the night long. And this is our group. We're a bit, it was an extreme. This was really extreme, but a really nice experience. And these were our nice GPUs that are always our best friends. Thank you.
So jury, please note to get an extra point for listening AC/DC during the night.